Now, I want to try this on a more interesting example. Let's take something like 40, x to the 4th, y to the 5th, plus 72, x to the 5th, y to the 7th, and we'll divide that entire thing by 8x squared y. It's beginning to look a little busy, but nothing is going to change about how we attack this problem. We'll break it up into pieces. And you can draw circles if that helps you remember, at least on the smaller problems. We don't have too many things added up in the numerator. So we have our 40x to the 4th, y to the 5th, divided by 8x squared y. And then we're adding to that 72, x to the 5th, y to the 7th, divided by 8x squared y. Again, we'll go ahead and divide 40 by 8. And the last time I checked, that gave me a 5. X, working with each variable individually, will be raised to the power 4 minus 2 using our quotient rule. Y is going to be raised to the power 5 minus 1 because there's a power of 1 hiding on this y. Plus 72 divided by 8 is 9. We'll have x to the power 5 minus 2 and y to the power 7 minus 1. And we can clean this up, leaving a 5. That is a 5. X squared times y to the 4th power plus a 9 x cubed times y to the 6th power. And you can go ahead and check that on your own. You'll want to make sure to write out this step for a while, not to leap right away to the 3rd or 4th line here until you've had a chance to practice it. I want to do one more example. So far, the answers we've had have been very neat and tidy polynomials. It doesn't always work out that nicely, but we can still use the same method. So I want to show you one of those. We'll take something like 5m cubed minus 9m squared plus 10m, and we'll divide that by 5m squared. Again, we're just going to break this up into pieces. So taking the first piece, 5m cubed divided by 5m squared. Well, minding our signs, we'll have a 9m squared divided by 5m squared, and then plus 10m divided by 5m squared. Now we'll apply our quotient rule and clean up the coefficients as best we can. 5s are going to go away. We'll have m raised to the power 3 minus 2 minus a 9/5. Well, m squared is going to cancel m squared, or if you prefer, just to remind you, I'll write out the quotient rule. We'll use the definition of a 0 power. And 10 divided by 2, 5 is 2. And we're going to end up with m to the power 1 minus 2, letting us practice with negative exponents here in a moment. So we have plain old m, power 1, minus 9/5, and this is going to give us m to the 0th power, but that's just equal to 1 when we do 2 minus 2, so we don't have to write that down. And now we have 2 times m raised to the power minus 1. But we can remember from our definitions for negative exponents, this is going to leave us with 2 over m. This is not a polynomial. the point here is that the quotient of two polynomials does not necessarily have to turn out to be a polynomial in and of itself. And by way of a recap, I want to write in different words. To divide a polynomial by a monomial, you are going to divide each term in the polynomial. That was the numerator in our problems, and yours. By the monomial, and then simplify. And that's the end of this segment.